Hello and welcome to Integration Video Series Video 3. We're going to have a look at indefinite integrals today. And in this video, these integrals are indefinite because they're kind of theoretical. We don't know what x values are involved in the question yet. And so we simplify them and integrate, but we're left with just, I guess, an expression as the integral and not a final number value for it. So we'll get the hang of it by looking at a number of examples. Now the overall pattern here is our method is to integrate, to find an indefinite integral. We integrate each term, we add 1 to the power, and we divide by the new power. And we also have to not forget to add c or add k at the end of it. And I'm sure you've had that explained to you by your teacher. Anytime we integrate and we haven't got any numbers to plug in, we have to leave it as a plus c or a plus k. So let's have a look at a few examples and see how it actually works. Okay, to integrate, to find the indefinite integral of x to the 3, we add 1 to the power and then divide by the new power. So here, if we add 1 to the power, we'll get a power of 4, and we'll divide, so it'll be x to the 4, and we'll divide by that new power, and we'll add c to it. So integral of x cubed ends up being x to the 4 over 4. In example 2 here, if we add 1 to the power, we'll get a power of 8. So we'll end up with 6x to the 8. And when we divide by that new power, we get an 8 on the bottom here. Now that obviously can simplify. We better not forget our plus c while we think of it. 6 over 8 simplifies into 3/4. So we can simplify that down to 3x to the 8 over 4 plus c. Just draw a line here to separate those. Okay, the integral, interestingly, of 4 becomes 4x plus c. So anytime there's just a number, there's kind of like an x that appears there. Now I could explain that a little bit better here. If we have a think of that up here, we could actually write 4 as 4x to the 0, because x to the 0 is equal to 1. 4 is actually equivalent to 4x to the 0. Now if we do our method on that and add 1 to the power and divide by the new power, we end up with 4x to the 1, so there's an x that suddenly appears there, divided by the new power plus c. And when you divide by a 1, it doesn't really do a lot, really. So we get 4x plus c. So that's how that one works. Interesting. Now we can think of something that doesn't look like it's got an x term at all. We can actually replace it with x to the 0 and kind of explain how it fits the same method anyway. Now don't be fooled by example 4 here. What this is equivalent to, and I'm just going to rewrite the question. I haven't done any integrating just yet, but I just want to show you that this is actually a legitimate version of what we started with here. The dx is sometimes written on top of the fraction, and it's quite annoying. It's frustrating as it kind of gets in the way there. But what I've written beside it here, the integral of 1 over x to the 5 dx, is exactly equivalent to what we started with in the black writing. So now we'll just go ahead and do our integration. Now, one other way we can actually rearrange this to help our brain a little bit, instead of 1 over x to the 5, we'll say x to the minus 5 dx. And now we'll be ready to add 1 to the power and divide by the new power. If we have to be careful with negatives, if we add 1 to minus 5 on the number line, we actually get minus 4. So we'll get x to the minus 4 over, because we've got to divide by the new power, over minus 4 plus c. Now we also have a bit of an obligation. I might move over here to do it because I've run out of a bit of space here. But we kind of have an obligation to turn our answer into as close as possible format to our question. So we started off with a fractional indice and not a negative indice. So I'm going to rearrange x to the minus 4 as I'm going to actually split it up into a fraction whereby we're multiplying by 1 over negative 4 times by 1 over x to the 4. And you'll see that that ends up being perhaps something along the lines of minus 1 over 4x to the 4 plus c. So that's pretty strange, I know, but if you have a look at each part of what I did there, it should make sense. But ask me if you're not sure. So that's the indefinite integrals, the first 4 examples at least. Let's press on and see where we go with our next few examples. Okay, example number 5 here. We've got integral of root x dx. I'm going to rewrite it a little bit by saying root x can be written as x to the half, can't it? X to the power of a half dx. So when we do our integration there, we'll be adding 1 to the power and then dividing by the new power. So we'll get, when we add 1 to a half, we get 1.5 or 3 on 2. So we'll get x to the 3 on 2 divided by that new power plus c. And when we rearrange that, we'll have, now when we're dividing by a fraction and we're dividing by 3 on 2, which is an improper fraction, we'll flip it and multiply there. So we'll actually get 2x to the 3 on 2 over 3 plus c. Now when we turn that back into a format that looks very much like our question, which we have a bit of an obligation to do, we'll have the following. We'll have, remember our flower power here, the top is a power and the bottom is a root on our 3 on 2 power there. So we'll have 2 root x cubed over 3 plus c. And so that's just us rearranging it to match as closely as possible to our original format, which had roots in it rather than fractional indices in it. Okay, question 6, let's have a look. Now this one needs a fair bit of rearranging here. What we need to do is split up the bottom term. The bottom term can distribute and be dividing into each of the other terms. So this actually ends up being, a rearrangement of this ends up being x to the 5 over x squared, separately to minus 3x to the 4 over x squared, plus 2x cubed over x squared. Better put that in brackets, I think, with a dx after it. Okay, now when we do our cancelling here, and this is even before we've done any integrating, we get that we'll just divide our x squared into our x to the 5 and we'll get x to the 3. We'll divide our x squared into our 3x to the 4 and get a minus 3x squared. We'll divide our x squared into our 2x cubed and get 2x dx. Okay, now we've just rearranged it, so it's now possible for us, even though we started off with a pretty ugly fraction here, to just integrate, or allows us to integrate just term by term. So we'll add 1 to the power and divide by the new power. This one becomes x to the 4 on 4 minus 3x cubed on 3 plus 2x squared on 2 plus c. And we'll just neaten up this, do a bit of housekeeping here. I think we're quite fine with x to the 4 on 4. Now these 3's will cancel out and end up just with minus x cubed. Our 2's will cancel, leaving us with x squared plus c. That's the simplest version of our answer there. So don't be fooled. It is possible to do a hard question like example 6, or it looks hard to begin with. Once you distribute that bottom x squared underneath each of the terms individually, once you cancel them through, you can get a term-by-term situation, and it's almost like you're answering a much simpler question by doing that. A couple more examples here. Now this looks tricky with two brackets happening, but not quite as tricky once we do one good first move here. So we'll expand that. Expand first. Expand first. Then we can integrate term by term. So if we expanded those two brackets, just doing FOIL or something similar, we'll get x squared plus x minus 12 integral dx. Then when we're just doing that term by term, we'll get x cubed on 3 plus x squared on 2 minus 12x plus c, and that's about it. So once we expand these two brackets and just get a quadratic out of it, this bracket is just a containing term by term opportunity for us to integrate there. Not too bad in the end. And just to reiterate, this one looks a bit different, but it's not too bad. Let's just adapt him so it helps our brain when we integrate here. Rather than 4 on top of x to the 5, let's make it the one term. So we want to be integrating 4x to the minus 5 dx, which then allows us to add 1 to the power, and be careful, adding 1 to minus 5 makes minus 4, it doesn't make minus 6. So we get 4x to the minus 4 on the new power, divide by the new power, plus c. We'll neaten that up a little bit and get the 4's cancelling out here. So we'll actually get x to the minus 4 over minus 1 perhaps, plus c. And then to neaten that up even further, we'll maybe just put the minus in front of the top of that fraction instead of the bottom. We get minus x to the minus 4 plus c. Now our original here was in fraction form, so let's turn this back into a fraction. We can make that minus 1 over x to the 4 plus c. And we've got it nice and neatly back into the same format really as our original question. Okay, one more harder example on the next page and then we're pretty much done. I know this video has gone on for a while, but we're getting some great examples shown here. Okay, this has got its own method here. We've got brackets here and we can't really expand it. I'd hate to expand something with a power of 8 there. I think that would take a long time. So what we're going to do is a bit of a chain rule thing. It's a bit of a function rule, this is called here. And we did a similar thing with differentiation, but not exactly the same. So let's have a think about it. Our step 1 is to integrate the bracket as if as a whole, as if it was just x to the 8. Now if this was x to the power of 8, we would add 1 to the power and make it x to the 9 over 9. So we'll kind of do that with the bracket here. So we'll have the bracket 4x minus 2 to the 9 over 9. And what also has to happen is step 2. We have to take the differentiation of inside the bracket, and I know we're doing integration, I believe you, but we actually have to do a little bit of differentiation in this function of a function rule here. Pretty weird, but still. And when we get the differentiation of inside the bracket, it goes underneath and joins any other numbers that are dividing here. So the differentiation of inside the brackets is just 4. So what happens is that goes underneath and joins any other numbers that are dividing. So that is times 4. That 4 down the bottom here came from the differentiation of inside the brackets. Don't forget our plus c. We can neaten that up a little bit and just say it's going to be 4x minus 2 to the 9 over 36 plus c. Pretty weird. Let me just recap on that one briefly. We integrate the bracket as a whole as if it was an x, and then our second step is to differentiate inside the bracket and divide by that differentiation result. So when we divide, it goes down the bottom and joins anything else that's down the bottom, and that's how we came up with our answer. So thanks for listening, and that's a whole bunch of indefinite integrals. When we don't know what x values to plug in or anything, we're just sort of integrating and finding an integrated expression. And don't forget your plus c every time. Thanks very much.